Fifth grade, chapter 9, lesson 1, line plots. Unlock the problem. Students have measured different amounts of water into beakers for an experiment. The amount of water in each beaker is listed below. So they had so many 1/4 cups, so many half cups, and so many 3/4 cups. If the total amount of water stayed the same, what would be the average amount of water in the beaker? So what they did was every time they saw 1/4, they put an X. So they put they used 1/4 and they put it right here, right? They did another 1/4 and they put it right here. They did another 1/4 and they put it here. They did another 1/4 and they put it here. Okay, so we need to keep putting X's until we run out of 1/4. So I need to cross this off and then put an X, right? Then do I have any more 1/4?
Yes.
Yep, here's another one, and draw another X. Do I have another one?
Yes.
Yep, and then draw another X. 1/2. Do I have a 1/2?
Yes.
Yep, how many?
2.
1, 2. So I put 2 X's here. 3/4. How many 3/4 do I have?
3.
3. So they already put 1 for us, and then 2 and 3. So count the number of cups for each amount. Draw an X for the number of times each amount is recorded to complete the line plot. So we did that, right? How many 1/4 do we put? So how many X's?
7.
7. How about 1/2?
2.
How about 3/4?
3.
Step 2, find the total amount of water in all of the beakers that contain 1/4 of a cup. So how many beakers have 1/4 of a cup? 7. So there are 7/4, or we write it 7/4. And then what's that that is an improper fraction, but what is it as a mixed number?
1 and 3/4.
1 and 3/4. So find the total amount of water in all of the beakers that contain half of a cup of water. So how many beakers have half of a cup?
2.
2 beakers with half a cup of water. So there are 2 halves. So 2 halves is also equal to
1.
1 cup. Find the total amount of water in all of the beakers that contain 3/4 of a cup of water. So how many were there 3/4?
3.
3. So they took 3 times 3/4, which is also equal to what? 9/4, which is also equal to
2 and 1/4.
2 and 1/4. So they said add to find the total amount of water in all the beakers. So they said 1 and 3/4 plus 1 plus 2 and 1/4 equals what?
5.
5, because 1 plus 1 plus 2 equals 4, and 3/4 plus 1/4 equal 1. So 4 plus 1 is 5. Divide the sum you found in step 5 by the number of beakers to find the average. So basically our sum was 5, and then how many total X's did we have? 12. So 5 divided by 12. These are both whole numbers, right? So what goes in the numerator spot?
5.
5. What goes in the denominator spot?
12.
So our answer, so the average amount of water in a beaker is
5/12.
5/12 cups. So what we did was we got our total, we added all of our things together, and then divided by how many X's we displayed. Okay? Try this. You can use the order of operations to find the average. Solve the problem as a series of expressions that use parentheses and brackets to separate them. Perform operations from inside the parentheses to the outer brackets, which that's your order of operations. Right, guys? Okay? So first of all, we have to do what first? You have to do parentheses first, right? So 7 times 1/4 is 7/4. 2 times 1/2 is
1.
2/2, which equals
1.
1. And then 3 times 3/4 is
9/4.
9/4. So then, now that we've gotten rid of our parentheses, then what do we do for order of operations? Bracket, right? Okay, and adding is in the bracket. So 7/4 plus 1/4 is 1 7/4. Okay, and then plus 9/4 is 1 16/4, which we know 16/4 converts into 4. So 4 plus 1 is 5, which we learned that in the last steps. So once again, we have a whole number divided by a whole number. So we put what in the numerator? 5. And we put what in the denominator? 12. So that kind of just condensed our order of operations, right? We did exactly what we did on the other side. It just kind of helped us put everything a little bit into smaller order. Example, Rain divides 3 2-ounce bags of rice into smaller bags. The first bag is divided into bags weighing 1/6 ounce each. The second bag is divided into bags weighing 1/3 ounce each. The third bag is divided into bags weighing 1/2 ounce each. Find the number of 1/6, 1/3, and 1/2 ounce rice bags. Then graph the results on the line plot. Write a title for your line plot. It should describe what you're counting. So what are we counting, guys? The weight of what? Okay, so weight of rice bags. And then what are we measuring them in? What's the weight in? In ounces. So underneath there, you need to put a measurement in ounces. Then label 1/6, 1/3, and 1/2 on the line plot to show the different amounts into which the 3 2-ounce bags of rice are divided. So they already did that for us, right? They already put 1/6, 1/3, and 1/2. Now use division to find the number of 1/6 ounce, 1/3 ounce, and 1/2 ounce bags that were made from the 3 original 2-ounce bags of rice. So they said 2 divided by 1/6, which really that is 2 times what? 6, which equals 12. Then they have 2 divided by 1/3, which is really 2 times 3, which equals 6. And then they have 2 divided by 1/2, which is actually 2 times 2, which is 4. Then it says draw next above 1/6, 1/3, or 1/2 to show the number of rice bags. So how many do we draw above 1/6?
12.
12. How many above 1/3?
6.
How many above 1/2?
4.
So that shows how much was put into each one, correct? Okay. Share and show. Use the data to complete the line plot, then answer the questions. Lily needs to buy beads for a necklace. The beads are sold by mass. She sketches a design to determine what beads are needed and then writes down their sizes. The sizes are shown below. So, do we need to go ahead and plot them on our line graph, guys?
Yes.
Yes. Okay. Now, when we go through to figure out how many there are of each one and we mark them off, should I scribble them out?
No.
No, I just need to put a simple mark because if I mess up somewhere and I have that all scribbled out, is that going to cause a mess for me later? Yes, so a simple line, right? All right, so 1/5, we need to go through and count how many 1/5s we have. 1, 2, 3. Is that all we have?
Yes.
Okay, so they already have the 1/5 for us, right? Okay, now 2/5. How many? 1, 2, 3, 4, 5. So you need to put 5 X's, right? 1, 2. Okay, 3/5. How many do we have of those?
1, 2, 3.
3. Okay, and then 4/5. How many?
1, 2.
Okay. Now, what is the combined mass of the beads with a mass of 1/5 grams? So how many X's did we have for 1/5?
3.
There were 3 x's above 1/5 on the line plot. So the combined mass of the beads is 3/5 or what? 3/5, right? Grams. What is the combined mass of all the beads with 2/5 grams? So we have 2/5 times what? How many were there, guys? 2/5 times 5/1. Can I simplify before I begin?
Yes.
Yep, these can cancel each other out, right? So what does that equal?
2.
2/1, which equals
2.
2 grams. Number 3, what is the combined mass of all the beads on the necklace? Okay, so we already have what this was, right? It was 3/5. We already have what the 2/5 was, and it was 2. So then we also need to find what, guys?
3/5 and 4/5.
3/5 times what? 3/1, right? Which equals what?
9/5.
9/5. And we also need to find the 4/5. So we would take 4/5 times what?
2.
Times 2/1, which equals what?
8/5.
8/5. Now what do we need to do, guys?
Add
Add. You need to add what?
9/5.
2 plus 3/5 plus 9/5 plus 8/5. And what does that get us? What's 3 plus 9 plus 8? Okay, so what's 3 plus 9? 12 plus 8 is
20.
20. So 2 and 25, which also equals 2 plus what? Plus 4, which equals, so 6 what? Grams, right? What is the average weight of the beads on the necklace? So what was our total?
6.
So it'd be 6 divided by how many x's do we have?
And 12.
Yep, how many total x's on the whole chart do we have?
11. 12.
We have
10.
3 plus 5 is 8,
13.
plus 3 is
11.
11, plus 2 is 13. So how do I write that as a fraction? 6/13, because we have 2 whole numbers, right? So 6/13 of a
Gram.
gram. And then that would be our answer.